So quite a bit we are investigating the limits of rational functions. There's 4 possible scenarios for when we have rational functions. So this is saying as we approach a of our rational function, the numerator is a non-zero constant and the denominator is a non-zero constant. So example would be the limit as x approaches 1 of x plus 1 over 2x plus 1. Here, if I plug in 1 in my numerator, I get 2, and I get 3 in my denominator. Both separate non-zero constants that are good for direct substitution. So here in this problem, the numerator is 0 and the denominator is a non-zero constant. So example would be limit as x approaches 0 of x over x plus 1. So if I do direct substitution, I get 0 over 1, which is 0. So once again, you can do direct substitution for those types of problems. So now this is where it gets a little bit more crazy. Non-zero constant in the numerator and 0 in the denominator. So an example would be, let's see, the limit as x approaches 0 of, let's say, sine, no. Let's say we make it, let's make it really easy. Let's just say 1 over x. Let's make it really straightforward. So remember, now we have a vertical asymptote in my denominator, so I need to check the right side and the left side. The limit as x approaches 0 from the right would be positive infinity, and the limit as x approaches 0 from the left would be negative infinity, so this one does not exist. But another example, let's say I have the limit as x approaches 0 of 1 over x squared. Once again, there's a vertical asymptote, but if I check the limit as x approaches 0 from the right, it's positive infinity. If I check the limit as x approaches 0 from the left, it's also positive infinity. So overall, it is infinity. So with a 0 constant, a 0 denominator, make sure you're checking both sides of that asymptote. So the last example, let's say the limit as x approaches 1 of x minus 1 over 1 minus x. That will give us 0 over 0. So I need to simplify. Oh, that's an indeterminate form. Once we get an indeterminate form, we need to simplify. So my numerator stays x minus 1. My denominator, I can factor out a negative 1, and that leaves x minus 1. So it's the limit as x approaches 1 of negative 1, which is negative 1. So in these instances with indeterminate forms, we simplify.